Let's take a look at this simple example. So we can see character is walking. Let's try to select some controls like I key controls, pelvis and main, add them to layer as usual, set a few keys, and maybe make some, let's say, adjustment. Maybe we would like to shift our animation. So everything will be sliding. Now we run the script and see that the sliding is gone. And the character is sort of strafing right now. We can use this effect to create strafe animations later, but it is a topic of the next tutorials. So right now what we need to understand, if we apply a simple offset algorithm, we will get a linear movement, a linear shift from the original position to some new position. And the same will happen if we apply the transformation algorithm, simply because the delta by transformation, again between original animation and the new animation, it's a simple shift by position. So with the transform algorithm, the result will also be linear. And right now, let's try to run the script in the transform by spline option and see what happens. So we can see that the character is walking on some sort of spline. So again, with the offset, we get a linear movement. With transform option, the result is the same because we didn't apply any rotation. And the spline option allows us to animate the walk on some curved trajectory. We can use this effect to create a lot of adjustments very quickly and easy. For example, this, I would say, classic case with a cylinder. So the character is going through some cylinder, and let's say we want the character to go around the cylinder. So I will add an extra key in the middle on all objects. Then I would relocate the main control. Everything will be sliding as usual. And then I will run the script in the transform by spline. And the character is going around this pillar. So here I'm using a standard motion trail, but we can make a preview of our adjustment with this little button. It will show us roughly how the result should look like. And when I move the character, the trajectory is being updated automatically. I can rotate the character or move the character, and you see how the final adjustment is changing. The trajectory is also changing its color, so it depends on the elongation of the path. You can find the metrics in the tooltip description. So when we elongate the path, it shifts its color to yellow, then orange, then red, and then white. And same with shrinking the path. So let's try maybe to make a little bit different adjustment with different columns. Again, I can rotate the character in the required spots, like this. And you see that trajectory is showing us the result adjustment. So after I run the script, the character will be walking around those colors. An important note here, so similar as we did with the transform algorithm, when we use transform by spline, ideally we would like to specify some sort of center object that would work as a pivot point for our transformation. So this is essentially how it works. We can move our character, rotate our character in layer, use this button to visualize the trajectory, and the script will build a nice and clean adjustment over some curved path. And we can use this technique in a lot of situations, not only walking around some columns, but for example to create some directional animations. So here I have a character doing some sort of flip animation, like a dodge animation. And let's say I want this animation end not in this point, but maybe in this point, like it's 45 degrees dodge. As usual, I would need to add some IK controls, pelvis and main to the layer. In some cases, we can also add the spine controls. So I will add controls to the layer, set to keys, maybe visualize the trajectory, and simply move and rotate my character in the required spot. So everything will be sliding. Now I will specify the pivot point for the transformation, which would be the main control, and run the script with the transform by spline option enabled. And I got the character jumping in completely different direction. I can easily create animations for different directions as well. For example, 90 degrees. I will have to recreate the trajectory. So it looks like this. Again, run the script with the transform by spline option. And the character is jumping to the right. If I need, I can add more keys to this adjustment. For example, maybe here the trajectory could be a little bit different. So I will select all controls, set one key, recreate the trajectory, and just move and rotate character exactly as I need. So the preview looks like this. Again, run the script. And I got the adjustment I need in literally few clicks. So in this way, we can create a lot of different directional animations very quickly and easy. Right? For example, to match the character with this locator, delete the key which we created before. So we got our character jumping like this. Again, run the script. And the animation is transformed to the required direction. Similar with jumping to the left. Again, match translation and rotation with the locator. Again, maybe we would like to add an extra key somewhere here. Just set key in layer for all objects and then relocate the main control. Run the script. And the character is jumping in the required direction. So with the minor adjustments, everything is kind of easy. The script does the work pretty well. But if you would like to create more extreme adjustment, like maybe minus 135 degrees, you would need to add maybe a few extra keys. So let's try to do this. Again, I will match main control with this prearranged locator. Maybe visualize the trajectory. And we can see that here the corner of the spline is kind of too sharp. So if I try to run the script, we will get a lot of turn in the beginning of animation. So we can add an extra key, maybe somewhere here. I will select all objects, set one key, maybe recreate the trajectory, and now simply relocate the main control. So the animation looks like this. Now I will run the script. And I got the character jumping in a completely different direction. And I had to add basically only two keys. And you can use this technique to create other directional animations. For example, some directional starts, skills, or attacks. For example, here I have an attack animation. And if I want to adjust it to a different direction, I can just select IK controls, pelvis and main as usual, add them to layer, set a few keys, and relocate main control exactly as I need. Let's visualize the trajectory. Again, if you are doing some minor adjustment, there shouldn't be any problem at all. Match translation, match rotation, specify main control, the object for transformation, choose the transformation by spline, run the script, and we got attack in a different direction. Let's maybe try to make a little bit more extreme adjustment. Again, much translation, much rotation, like this. Run the script, and the animation is changed to the required direction. If we have problems with the legs overextension, because the path right now is elongated, we can use pelvis correction. You can find more about the pelvis correction in the first tutorial. Right now I will just load the config. New selected config, specify namespace, and run the script with the pelvis correction enabled. So animation is adjusted similar as before, but right now, like in these problem spots, pelvis correction helped us to deal with the legs overextension. I will skip other directions because I think idea is pretty clear. So with this technique, we can easily create animations for different directions, for the attacks, starts, skills, dodges, and similar cases. Well, of course, if you're talking about the AAA studio, it can just hire a professional stunt actor and record everything in mockup, but not everyone can do this. And still, if we are working on the animation prototype, like combat systems or locomotion systems, this approach can save us a lot of time during animating. And of course, the application of the script is not limited by adjusting only walk animations or simple directional animations. You can adjust anything you want. So for example, here I have a guy climbing some wall, and let's say we want to make a climbing by some spline. We can easily do it. So same as before, we need to select some eye key controls, pelvis, main, and maybe eye key controls for hands. Add them to a layer. Set the required keys. Then we would need to specify a center point for the spline transformation. In this case, I think the pelvis control will work better. And maybe visualize the trajectory. So we have our animation like this. And if I relocate the main, the spline is updated. And if I run the transformation by spline, the character will be climbing along this spline. So here we can see that the character remains vertical. It's because we disabled the vertical rotation. If I enable vertical rotation and run the script, we will see that result will be different. The animation will look like this, which is not very realistic. So depending on the circumstances, you might want to enable vertical rotation or disable. Let's maybe take a look at a different example to explain the vertical rotation. So here I have a regular walk cycle. And as usual, I would select some controls and add them to layer, set a few keys, maybe visualize the trajectory, and specify the main control as a point for the transformation. So if we add some vertical movement and run the script, by default the character stays vertical. And if we enable the vertical rotation and run the script, we will see that the character is sort of moving along this spline. So in order to explain this, we would have to imagine an up vector. So it works like this. The script has some up vector, which by default is the same as the scene up. And we have to imagine an orthogonal plane to this vector. So the yav rotation will be considered as horizontal, and the pitch rotation and roll will be considered by the script as a vertical rotation. So when we make a transformation by spline, So imagine this is our character moving, let's say from point A to point B. So the script takes a vector of this character, some sort of direction, and then takes a vector from spline, for example, like this. Then it takes a projection of this vector to this horizontal plane, and by using the projected vector from spline and original movement vector, we can construct a rotation and apply it to our character. So in this way, we can ignore the pitch and roll components of rotation because we take only projected vector, not the original, and avoid situations where the character is walking like this and choose a different result like this. But in situations like this, we have to be a little cautious. I will show what I mean. So for example, here, if I have the movement maybe like this and run the script, the result might be not correct because you see we have this twist problem, and it happens because how the vertical rotation is defined. So in this example, we have vertical rotation same as the scene up. So it would mean that here we have the scene up like this, and that would be a horizontal plane. And initial vector is also up, and the projection of this vector will be a very small value, almost like a dot. And when we get the rotation from spline, some tangent vector, again, it will be a very small value. And because the original vector is not very precise and the projection is not very precise, we would get a lot of inaccuracies by the twist rotation. So to avoid this problem, we can redefine the up vector. So for example, if we tell the script that up axis is not y, but maybe some other axis, maybe like x, then the up direction will be like this. The horizontal plane will be like this. And our initial vector, which is going up, will get a full projection to this horizontal plane. And the vector from spline, again, will get a correct projection. And we will be able to construct an angle from these two vectors, and everything will work as expected. So right now, if I change the up axis to some different value, for example, the x, everything should work correct. All right. We have our character climbing some spline, and we don't have any issues with the twist axis. And we got the vertical rotation in a different plane. So the script has very flexible settings in how do you define the up direction. So it can be some axis like the scene up or any custom direction. Also, you can specify an object to define the up direction. For example, here, if let's say we have some, I don't know, character walking in some space station or something, we can create a custom object. For example, like a locator. Move this locator somewhere here and just parent constrain it to the main constraint parent. So right now the locator is following the main control, and I can specify this locator as a up object. So the script will build a vector from the center object to this up object like this, and it will think that this is up direction and the horizontal plane will be perpendicular to this up direction, and we can apply any adjustments even in this complex example. So if I select IK controls pelvis and main and add them to layer, maybe set a few keys. And let's say here the character has to go up in his own unique direction. Maybe here I will select all objects, set one key. Let's say move the main control a little bit up. Maybe visualize the trajectory. So because we specified the up object, the custom object, the vertical direction will be defined correctly, and we will get correct adjustment by spline. So the character stays vertical in this case. And again, if we enable vertical rotation, the character should receive the rotation from the spline, like this. So in most of the cases when we deal with simple walk animations or simple directional animations, it's not very important. You can just keep the up axis same as the scene up and maybe disable vertical rotation. But when we want to adjust some unusual case, like here, where the character is climbing vertically, this vertical rotation might be an important setting. And here we can see another example. So we have a character climbing some surface, and let's say we want to adjust this animation by spline. It's not a problem for the script. The only problem which we can face here is that it is not very convenient to manipulate the main control. And also we have hands in a different space, not following the main. Here in this case, I would say we need to use some point maybe here instead of the main control as a center of mass for our transformation. We can easily do it with space switching. So for example, I will select this control of the spine and maybe simply back it to the world space. Maybe scale it up. Maybe change its color. So this would act like a new main control. We can call it temporary main. So right now it controls only this segment of spine because we baked it to the world space. But again, not a problem for us. We can select maybe main control and this hands eye case, then select this temporary main and simply switch space inside. I will talk more about space switching later. It's kind of the topic of the next tutorial. But here all we have to know is that we kind of recalculated the movement of these controls. So the animation looks the same, but right now they're sort of existing inside this new main control. And maybe I can hide these controls. Alt eye case, they are not important anymore. And I can add these controls to the layer. Set keys where I need. Maybe visualize the spline. And maybe set it as a center object for the spline transformation. So right now I can move this main control and the animation will be transformed along the spline. Alright, so the character is climbing along this new path. In a similar way we can do like a circular climbing, it's not a problem. I can maybe create the helper rig for this control. Now I can rotate the helper rig and using the transform algorithm, it will create me a nice and clean circular climb animation. So again, we are not limited by only circular movement. We can also apply some vertical movement. It's not a problem for the script. maybe like this. So everything is sliding as usual. Now, if I run the script with the transformation by spline, the character will climb to the new point. If I enable the vertical rotation, the result will be different. Let's see what I mean. Again, run the script with the vertical rotation. So we will see that our character is kind of rotated along the spline vector, and maybe this is not exactly what we want. So again, use vertical rotation when you need it. In other cases, like here, maybe it's better to keep it disabled. Here is another example. So we have a character walking some stairs, and let's say we want to make some spline adjustment. It's not a problem for us. Again, we can select icon controls, pelvis and main, add them to layer, maybe set a few keys, maybe visualize the path. So let's say I want the character be not in this point, but maybe in this point. So everything will be sliding. And okay, I need to specify the center point for the transformation as usual. Then just run the script. And the character will be walking on these stairs according to the spline movement. Also, if we want to make, let's say, movement over some curved stairs, we can also do this with the spline. But in this case, I think the transformation algorithm will be better because it's like ideal circle movement. The spline provides us not a perfect circle, but a little bit different shape. So if you want to make some circle movement over these curved stairs, we better use transform algorithm. So again, this is the start of animation. This is the end of animation. I have a layer with all objects. Maybe I can visualize the trajectory and simply move my character here, rotate it accordingly, like this. So everything is obviously sliding. Now I can run the script in the transform algorithm, and I will get a nice and clean walk over these curved stairs, where every step will be exactly in the correct spot. And like I said, with the spline, the result will be not so precise. Let's try to run the script with the spline option. And again, it worked at some degree. But here at the end, I think here we have some inaccuracies. Because again, the script will try to build some spline, and there is no guarantee it will go along this specific surface. I would say it would go like this. So in some points, the character can go through geometry. So depending on the circumstances, you might better use the transformation algorithm. Another interesting feature of the spline would be automatic leans. So for example, here I have a character walk, and let's try to add icon controls, pelvis and main in layer as usual. Set one key. I will use helper rig to adjust this walk, maybe with 3 segments. Then maybe visualize the trajectory of the main control. So if I bend these segments, the keys in the layer will be updated automatically. And as a result, if I run the transformation by spline with the main control as the pivot point for the transformation, we will get a walk over this path. And like I said, we can apply automatic leans, similar as we did with the transformation algorithm. and we get our character leading towards the inner part of a turn, like it is happening in the real world. So under the hood, a real physics world formula is used to calculate those lanes. So depending on the dimensions of your scene, the results might be different. So you might want to play with the strength parameter. Here I have the scene in the real units with the real size of a character. So everything works kind of okay. But again, if you have your characters, let's say, scaled to some factor, the results might be different. And here with the lanes, we have a little bit of it sliding. A tiny sliding. If it's a problem, we can fix it with a fixed sliding algorithm. Again, just select feed controls, add them to layer, set one key, select the feed sliding, the threshold, I don't know, maybe 1% because it's a very small sliding. Then run the script. Let's maybe take a look at the debug. So in the debug, we can see that we better to take maybe 1.5% as a threshold value, maybe even 2%. All right, not a problem. Let's try again with 2%. Run the script, and the sliding is completely gone. So about the smooth parameters in the lanes, it's kind of important. So let me show what happens if I run the lanes without any smoothing. We will get a very sharp transition, because in this segment the lane is happening towards this direction, and in this lane it is happening towards some point here. So here we have a sharp transition, and the smooth parameter allows us to distribute this transition. So if we pick some value, I don't know, maybe 20 frames, maybe more, the result will be okay. But again here, because we smoothly interpolate the lane, we can get a tiny feed sliding. But it's not a big deal for us because we have a dedicated algorithm to avoid this problem. The lanes can be applied not only to walk cycles or movement cycles, but basically to any other animation. So for example, here I have animation like this, where the character is moving along some rope, and we can adjust this animation by spline as well. Not a problem. The only issue here would be that the center point for the transformation, it should be not the main control, but maybe some point here. So here we can use the space switching again. Maybe we can create like extra main control from one hand IK. I will just create animation snapshot. Maybe make this locator bigger. Maybe color it. And rename in the temporary main. I think I don't need a rotation on this locator, so I will go to the graph editor and delete all rotation keys and just set rotation as 0. So right now we have a locator repeating the hand movement by position, and all we have to do is to switch space. We have to select the main control, which controls the body, and also the IK controls, then this our temporary main, and simply bake it inside. So animation is not changed visually, but right now this main control, it controls the movement of the whole character, and I can easily apply adjustment by spline. So I will select this main, our extra locators, which were created when we switched the space, add them to layer, maybe set one key. I think it would be easier to use the helper rig, maybe with 3 segments, and maybe visualize the trajectory. Also, we need to specify the pivot point for the transformation, which would be this temporary main control. And right now, by rotating the helper rig, I can transform this animation along some spline, for example, like this. So right now everything is sliding, but if I run the transformation by spline, our character will go along this curved trajectory. And like I said, we can run the lanes in this case like this. And we got our character rotated according to his movement. So here, because I created the layers in the override mode, I can play with the lens opacity. So this layer is with lens enabled, and this layer is without any lens. If I change the rotation accumulation from by component to by layer, I will be able to play with the layer opacity. We can even animate this opacity. For example, here we can set a keyframe in the opacity 1. Here we can make it, let's say, no 0. And here make it 0 again. So in the graph editor, it looks like this. The lens intensity slowly increases and then decreases back to 0. And our animation looks like this. And all happened automatically by the script. So if you have a longer path with a more complex movement, with a lot of curved movement, the feature of automatic lens maybe can be useful for you. Let's take a look at this example. So here we have a multiple characters walk. And if you want to adjust this walk of this group of characters by some spline, we can do this, because for the script there is basically no difference. Are we adjusting one character or a group of characters? If you take 4 characters, essentially for the script, it will be like a one giant character with a lot of legs. So same as usual, we need to select IK controls, pelvis and main, but do it for all 4 characters. So here I do not necessarily need to select the pole vector controls, because they already follow the IK feed. So I will add an animation layer with these controls and then set a few keys, maybe in the beginning of the time range, maybe in the end. And right now, if I manipulate those characters, the result will be some spline walk. If I would like to rotate the whole group of characters, it might be a little bit problematic, because again, in Maya, by default, when we rotate a group of objects, each object is kind of rotated separately. So if you have an animbot, you can use a temporary pivot tool to rotate the whole group of characters. Here on this machine I don't have animbot, so I can use another option called the helper rig. So I selected main controls of my characters, and right now I can create a helper rig, and this helper rig will work sort of like a temporary pivot. So you can see it is created in some sort of middle point between all 4 characters, and if I rotate this locator, my group of characters will be rotated around this locator. So the helper rig can help us to manipulate some complex objects or groups of characters. So I can again rotate my helper rig, and it will update all keys in layer automatically. for this whole group of characters. I can visualize the trajectory. It might help us to understand what is going on. So here we have two separate trajectories. So it's because the inner part of a turn is shorter, the trajectory changed its color to blue. And because the outer part of a turn has a longer distance, the trajectory changes its color to some orange. Okay, maybe let's try to run the script. We won't specify center object, because for this complex case, I think the average position should work perfectly fine as a transformation point. Okay, the script worked, and we can see our characters walking over the spline all together. So here we can see something interesting. When we launch the script in the default settings, it's kind of trying to preserve the shape of a character. So the end pose and the start pose will be exactly the same as in the original animation. It's kind of helpful when we work with animation for games, but here maybe we would like to slightly distort our group of characters, maybe make those two closer to each other, and maybe these two can be on a bigger distance between each other. So we can use a flexible pivot option in this case. It will provide us the desired effect. So with a flexible pivot, we can see that our first pose is no longer the same as before. The group of characters is slightly bended towards spline direction, and during the walk, you can see that these two characters are closer to each other, these two are further, and it looks a little bit better. Here we can notice another problem. Because this part of the trajectory is elongated a little bit, we can see some legs overextension. For example, here, there is clearly not enough length of the legs to cover this distance, and on the opposite, because steps are shorter, the walk looks a little bit weird. So in order to fix such problems, we can use the pelvis correction. We discussed the pelvis correction in detail in the first tutorial. Right now I will simply load the config, MetaHuman, and because I have 4 characters, I need to load 4 configs. And also I need to specify namespace for each character. Maybe we could create some debug line, and let's try to run the script. Okay, this is interesting. So we got 4 layers with pelvis correction in the scene, and where we had problems with the legs overextension, our pelvis correction moved the pelvis down. For example, here, if I disable the pelvis correction, we have problems with legs overextension, and with pelvis correction enabled, it looks kind of okay. And for characters on this side, the pelvis correction moved pelvis up, again to avoid weird look during the walk. So this is original animation, overextension, and weird look, and this is with pelvis correction. And of course, with the pelvis correction, you can always go to the graph editor and play with the curve filters, maybe apply some smoothing, maybe play with intensity, or maybe interpolation, to achieve the desired results exactly as you want. Let's maybe take a look at this example. So here we have a quadruped character doing some walk animation, and let's say we want to adjust this animation to make it walk over some spline over the surface. Same as usual, I will need to select eye key controls, maybe pelvis and mine. In this case, maybe I need to also select the neck controls, because it's a quadruped character. Then I will edit to layer and set 1 key in the beginning of the time range. We can relocate the main control manually, or maybe we can create the helper rig, maybe with 2 segments, I don't know. And maybe visualize the trajectory. So right now I can manipulate this helper rig, and it will relocate my character in layer exactly as I want. So here I quickly positioned my character on this surface. I did it manually. There is a way to do it faster, but in this case I just did it manually. So we can try to run the transformation with Spline. So as usual, we need to specify the main control of the character as a pivot point of the transformation. Then maybe enable flexible pivot because it's a quadruped character. We want it to be flexible to follow the spline. For the bear, I know that the value around 70% works the best because it's kind of a fat character and we don't need the 100% flexibility in this case. Also, we can enable the vertical rotation. If we're making the walk by spline with some inclined surfaces, for the quadruped characters, the vertical rotation option usually should be enabled. And we can run the script. And we can see that our character is walking over the spline and it is flexible. And also we get some vertical rotation along the tangent vector of the spline. So the character matches the surface. Here we might have slight issues with the legs overextension, simply because the path is elongated. I elongated the path on purpose to show you how to deal with this problem. So obviously the first way to fix this would be the pelvis correction. We can apply pelvis correction not only for biped characters, but for quadruped characters as well. Here I have a config file for the bear character. It looks basically the same as for biped, but with a few minor differences. It has more joints in the legs chains, and also it has a separate segment of the chest and the front legs. So I will use this config, specify namespace from this character, and run the script with the pelvis correction enabled. Okay, it's kind of worked. We can see some debug lines in the scene. So with the pelvis correction, the problem spots of our animation are fixed automatically. So here what it was without correction, and with correction, the animation is adjusted to fix the legs overextension. And same happens in many different spots. For example, here. So depending on your specific animation, the results may be different. In some cases, you might prefer to play with the values in this layer. Maybe go to the graph editor, find these pelvis objects, and maybe smooth this case a little bit using the curve filters. In some cases, maybe smooth it a little bit more. Maybe play with the intensity, for example, here. So it's not 100% super accurate solution, it's more like approximation, but again, with the curve filters and a little bit of polishing, it can work, I would say, quite well. So as a result, character is walking on the surface, everything kind of works fine. And another way to fight with the legs overextension would be to use distance option. It makes the script to evaluate spline in a little bit different way. So right now, we have 3 keys in our scene, and the script will force put character in all these 3 keys, no matter how path is elongated between. And use distance option, it will calculate the original length of the path, gutted length, and then we'll try to calculate length of this path and find such points where the length of this new path will be equal to this original path. So as a result, we will not stretch our animation. The character will still go over spline, which will look exactly like this, but because we use distance, and this distance will be exactly the same as the original one, the character will simply stop before it reaches this final destination. So as a result, the bear will stop somewhere here, and we won't get the leg overextension problem, because again, the distance of the path will be the same. So I will disable this layer, maybe disable the pelvis correction and run the script in the transform by spline mode with the flexible pivot and distance option. So you can see animation looks maybe a little bit better. We don't have legs overextension problem, but the character has stopped before reaching the final destination, again because the script, it took the length of the original path, projected this path to the spline, and made sure that the character will walk the same distance. So the distance, I would say this is the most precise way to evaluate spline, and if you don't care about the character being in the exact required spot in the end of animation, we can use distance. There is also an option to use distance with stretch. It will use the same distance, but it will kind of stretch the whole path of a character, and the result might be not so great. Let me show what I mean. So here, when we use distance and stretch, and because our path was stretched, our character is stretched as well with this path. And in most of the cases, I would say we would like to avoid this when using the quadruped characters. This was without stretch, and this is with stretch. And when we don't use distance, the path is stretched as well to match the required poses, but the character is not stretched because the script is using a smarter algorithm to bend characters over spline and without actually changing the length of the character. So it's some sort of a hack in the code, and it works quite well when we use simple animations. However, if we use complex animations, we better use distance. I will elaborate on this point in the next example. So here we have an interesting example. Our character walks forward and then starts to walk backward and then forward again. So the path is kind of complex. It's not simply going from point A to point B. And let's try to transform this animation by spline and see what happens. As usual, I would select IK controls, pelvis and main, and add them to layer. Specify the main control as a pivot point for the transformation, and maybe create helper rig with 2 segments, and also visualize the trajectory. So I can try to bend the helper rig to get the spline walk over some curved surface, and turn the script with the transformation by spline option. So we can see that the result is kind of a little bit weird, that the character is kind of following far away from the spline. And it happens because how the script evaluates the weight for the spline. So in order to transform character by spline, let's say from this point to this point, we need to calculate some weight parameter, let's say from 0 to 1. And usually we use an accumulated speed of a character to drive this weight of this point on this spline, and the accumulated speed is always goes from 0 to 1, which makes it very convenient to drive some adjustments in layer. But for this case, you see, because the character first walks forward and then backward and then forward again, we better use not the accumulated speed, but an actual distance, which would show us how the character moves in space. So with the distance, the weight can go first up, then when character will go backwards, it will go down, then when character will go forward again, it will go up again, and as a result, the animation will be transformed precisely. So if I run the script with the distance option enabled, the result should be correct. So here I have a character going forward, then backward, then forward again. And it's not a problem for the script to evaluate such complex animation. So I would say when you have complex examples, not just simple symmetrical walk cycle, you better use distance. It would give you the most precise results with the spline evaluation. Here in the tooltip, you can find an exact description how this distance option works. It might be a little bit confusing, I understand, and you can ask why not use distance in all cases. The answer would be because not in every case we need to use distance. Again, it's only specifically for the spline and maybe circle walks to achieve precision in adjustment. And when we are doing some turns on spot or maybe some simple shift, we don't need to use distance in most of the cases. It can be used with offset algorithm as well in some rare cases. Sometimes when you work with really weird animations, the use distance option can help you. But again, it's not super easy to find such an example. If let's say we have our weird walk animation, wherein the character first walks forward, then backward, then forward again. If I don't use distance and apply some offset to this animation, kind of like this, and run the script, you will see that my adjustment will go sort of equally on all animation. So the character makes longer steps here. When the character walks backward, it just makes shorter steps backward, and then it makes longer steps forward again. So again, the adjustment in layer always goes in one direction, and with distance, if I run the script in the offset mode, the result will be different. So the character will make longer steps forward, and then it will make longer steps back, and then again longer steps forward. So our adjustment in layer, you can see first it will be increased, then it will go in the reverse direction, and then it will go forward again. So as a result, it looks like our animation, it was some sort of scaled around this point. So again, when you use an offset algorithm with distance, you should be kind of careful. I would say this is kind of advanced option for advanced understanding. Maybe I will provide more examples in the next tutorials how exactly use this option. But for now, what you need to understand, when we create spline adjustment with a complex animation, the distance option will help you to get the precise results. And here I have another interesting example where we can use distance. So here we can see a kind of funny bear animation, where the bear is first works like a quadruped, and then becomes a biped character. Thank you very much, Gustavo, for such nice animation. And because this animation is kind of complex, first the bear character is quadruped, and then it becomes biped. So by default, when we enable the flexible pivot option, the script defines a center object and uses as a point to build the spline, and each object of our character is defined a unique pivot, and the position of this unique pivot, it depends on the average distance of this object to our center point. And when we use simple animations like walk cycles or any other movement cycles, it usually works quite well. However, here, because we have complex example, the standard way to evaluate this will be not exactly correct. Again, enough with the theory. Let's create a layer with our controls, then maybe create a helper rig with a few segments, I don't know, maybe 4 segments. Then maybe visualize the trajectory, and I will bend this walk. So we got our path like this, and I can specify the center point for the transformation, which will be the main control, and enable flexible pivot. And if I enable the distance option, everything should work as expected. So as a result, we can see our character first walks like a quadruped character and smoothly follows the spline. Then it becomes a biped character and again walks along the spline. And we have no issues in script to evaluate such complex animation. And if we try to run the script without distance, the result will be not exactly correct, because again, in our animation, the distance from object to center object is not constant, it is changed over animation. So without distance, the result will be not exactly precise. So you can see, like in the beginning of animation, character is not flexible enough. And here we have some weird result with the bear neck. So clearly we have some issues. So use distance option is kind of the closest approach to a classical spline approach. And later in this tutorial, I will explain how the classical spline works and how smart layer is different. So this distance option, it works more like a classic spline by the NURBS curve. So originally the script was designed to make simple adjustments, straightforward and obvious adjustments. However, if we want to make some complex walks over some complicated trajectories, it is still possible. We still have some tools to do this. But before explaining this part, I would like to go through a little bit of theory, explaining the classical spline approach and how the smart layer is different, because it has a little bit different philosophy from traditional tools. And after the boring theory block, we will get back to these complex examples and see how to make the quadruped walk over some complex terrain and do this very quickly and easy. So you might have noticed that the transformation by spline in smart layer is a little bit different from what we can call a traditional approach in transformation by spline. Let me explain what I mean. So for example, here I have a scene with cubes walking, imitating the walk cycle. And traditionally, if I want to adjust this animation by some spline, I would have to create some curve along this object's movement, like this. Then I would need to rebuild this curve to have a weight from 0 to 1 and correct number of spans. Then we usually create some locator with motion pass and animate this motion pass to match the cube's movement. So in every point of the cube's movement, the locator will be somewhere here. And then all we have to do is to switch space from this cube inside this locator, as this cube would have been a child object of this locator from the start. And the same thing we have to do for another cube. Again, create locator with motion pass, then switch space of this cube inside this locator. So as a result, when we deform the curve to some other position, the motion pass locators will follow the curve, and the cube will follow the motion pass locators. And as a result, our animation will be transformed around this curve. So it sounds maybe a little bit complex, but it's not very hard to do. We can do it even manually. So let's create some curve. For that, I will create a few locators. Maybe make them bigger. Maybe color them. So this is the start point. This will be the end point. Now I will go to the modeling, choose the curve tool, and create a curve with the snap option enabled. Okay, the curve is here. We can delete locators. Now this curve has only 2 vertices, so I need to rebuild this curve. Again, I will go to the curve, rebuild, choose the desired number of spans, and weight from 0 to 1. Okay. Now I need to create the motion pass locators. Again, create locator. Maybe scale it. Maybe color. Then select the curve, the locator, and go to the animation tab, constraint, motion pass, attach to motion pass. So right now our locator is following the curve, and we need to animate this locator according to the cube's movement. So the most correct way to do this would be to use closest point on curve node. It works like this. It can take some position and find a value on this curve, like UV value, which would match the closest point on this curve. I think for the demonstration, we can use a little hack. We can just go to the cube, go to the graph editor, find its translation, just copy it, go to the motion pass, and just paste. And I need to scale this curve to have values from 0 to 1. Okay, so right now our motion path locator is animated exactly like the cube, and all we have to do is to switch space. So it can be done with a script. Maybe let's do it manually for now. I will call it motion path. Now I need to create one more locator for the cube. Again, maybe scale it, maybe color. And I need to parent this locator inside the motion path. So it would be like a child object. And right now I will select the cube, the locator, and just run constraint parent without an offset. So our locator is following the cube. It exists in the motion path. All I have to do right now is to bake this locator and delete constraint. So we got our locator repeating the cube movement. And right now we can select the locator, the cube, and run constraint point, constraint orient. So animation looks the same, but our locator, it is controlling the cube, and it exists in the motion path, which is being controlled by the curve. And if I deform the curve, our animation will follow it. So let's quickly do the same for the other cube. Again, create locator for the motion path. Select curve, select motion path, constraint motion path attached to motion path. Maybe I will scale it and assign a color. Now we need to animate this motion path locator according to the cube. Again, go to the graph editor. Simply copy this curve. Go to the motion path. Paste. And scale it to have values from 0 to 1. Alright, the locator is animated exactly as we want. So same as before, we need to switch space of this cube inside this locator. I will create another locator, maybe assign some color, put it inside the motion path, constrain it to the cube, then bake, delete constraint, and constraint cube back to this locator. So animation looks the same, but again, this locator, it controls the cube. It exists in the motion path, which is being controlled by the curve. So right now, if I go to the modeling, curve and lock length, I can manipulate this curve and the animation will follow it. Kind of like this. And obviously without any sliding, because again, our motion path locators are animated according to the original animation. So this technique is usually what we do when we want to adjust animation by some spline. It's been known for many years and there are a lot of tutorials how to do this. Recently I found this tutorial which shows everything in detail, including the closest point on curve node. I will put a link in the description. Also, like manipulating the curve like this is not super convenient way. So usually what we want to do is to create some extra rig on top of this curve. For example, with cluster deformers, or maybe create some structure with locators, or maybe joints. But overall, all these systems with the curves, they work similar. They have some animated motion paths and a system with locators. So the classic approach can be scripted as well. I spent a little time and wrote scripts to automate all required steps. So for example here, if we want to adjust this animation, we need to create some curve. We can use main control, and the script passed the curve. It just baked me all positions of the main control to this curve. Now I need to rebuild it to have weight from 0 to 1 and the desired number of spans, like this. Now I need to select IK controls, pelvis and main, select the curve, and run the script, which would create the motion pass for every object and switch space inside this motion pass, which would follow this curve. So we can see that some system with locators is created in the scene, and if I change the curve, like this, my animation will be changed with this curve. So as a result, the character will be walking around this column. So after adjustment is done, I need to bake these controls and delete all extra systems in my scene. And we have our animation adjusted. So the classic approach has some advantages and disadvantages. The main advantage is that it is very powerful, and because we have an actual curve in the scene, we can use the full power of Maya. For example, we can create some deformers like blend shape or wrap deformer or maybe sine deformer and get a very interesting results and achieve a precise control of our animation. And the main disadvantage, in my opinion, would be its complexity. For example, here we have a very straightforward goal of our adjustment. The character was here, and we want to put it in this spot. So it's only minor adjustment. But in order to perform this adjustment, we have to follow a lot of steps. Like it was said before, we need to create the groove from a pass of the object, then rebuild to have the correct weight and number of spans. Then we need to bake our objects to this curve using the motion pass. Then we can make our adjustment, but in a majority of cases, I would say you would prefer to create some extra rig to manipulate the curve. Then finally we can make our adjustments. And after adjustment is done, we need to bake everything and delete all extra objects. So you can notice this is kind of a lot of steps for a very straightforward adjustment. And we have to know exactly what we are doing. Otherwise the results might be not so good. And we kind of trying to solve this task in reverse. So in order to move the character in the required spot, we have to go through all these steps in creating some extra system in the scene, then manipulating this system in order to put our character in the required spot, then bake and delete extra objects. And if we want to apply any different adjustment, we would have to start over again from the step 1. So some time ago I was working on some creature locomotion, and I had to do a lot of directional starts, circle walks, and turns animations, and I was using the classic approach to achieve this. And at some point I found myself more fighting with all these curves and rigs in the scene rather than actually animating. So then I had an idea. What if instead of following all those steps, we can just simply make our adjustment in layer and then just press one button and the script will do all the math, how the character should move. So it should be some vault by spline. The script will do all the calculations and bake everything to layer. And I don't have to deal with any curves with any rigs or motion path nodes, I can just move my character directly in layer, exactly as I need, press one button, and the script will do all the math. So in my opinion, the approach in Smart Layer is much simpler and faster, and you can do a lot of adjustments very quickly and easy, without being worried about any curves. Obviously, it does not provide such precise control, which you can get with the traditional approach, but especially when we work in the game animation and we have to deliver a large count of animations per day for the locomotion systems or the combat systems, I think the approach with Spline from layer is much quicker to use. And also, when we add the motion path to the scene, let me quickly recreate. So right now I have the walk following the curve, and we have this motion path, and because of this motion path, our scene becomes kind of slow. I believe this motion path, it acts like a bottleneck in the rig evaluation, and if I try to lock the length of this curve and try to manipulate, it will be basically unusable. So if you have a simple rig, it might be not a problem. Here I have one metahuman, and with this metahuman, everything becomes super slow. So again, when we are using the approach with the spline from layer, we don't have such problems. Because basically what we are doing, we just manipulating character in layer and everything works real time, obviously. Another painful moment which we can face when working with traditional spline is keeping the same poses. So for example, here I have a bear start animation. And let's say I want to make a directional start. So as usual, I need to bake this movement to some curve. Then rebuild it. Then select the required controls and bake them to curve. So now if I lock the curve length, I will be able to manipulate the character. But again, this is not a super convenient way to manipulate the curve. You see, like the curve is sort of fighting back to my adjustment because of this lock length option. So I will undo this and create some simple rig with joints. Now I can rotate the joints and the animation will follow it. So let's try to create a directional start. I will maybe rotate joints like this. And this looks already like a directional start. However, we have a problem here. So you see, because we are using the curve, our first pose is changed by this curve, and we cannot put animation like this in engine. If we make in the start animation, the first pose should be idle without any change, and if we put animation like this, the blend in engine will happen from original idle to this pose, and it will look very ugly. So in this case, we would have to apply some maybe extra layer, apply a pose from layer, then control the fit behavior to avoid sliding. So this brings us some little bit of extra work, and we would have to spend some additional time to adjust this animation. And if we use the approach with spline from layer, we don't have such problems. I will add my controls to layer. Again, set only 2 keys. Specify the center object, maybe visualize trajectory. Relocate the character and rotate like minus 90 degrees and put in the required spot like this. So here I have an option to keep the original poses. I can specify the blend time, for example, maybe 30 frames for the start and for the end. And when I run the script, my first pose will be exactly the same as in the original animation. And I get a smooth transition with character turning without feet sliding. And I don't have to do any extra work to adjust this animation. Maybe I could do a little bit of manual polishing with these controls, maybe add them to another layer and animate them like this. So the head will be turning before the rest of the body. But this is more like a minor detail, which is easy to adjust. And the most important part, that we keep the same poses. So we can basically use this animation as it is in game engine, and everything will work as intended. Another headache when using the classical spline approach would be the vertical rotation. For example, here I have a bare walk baked to some curve, and I have joints controlling this curve. And for example, if I would like to bend the trajectory like this, I will instantly get issues. The character will be shrinked. Then when it goes over 90 degrees, we will get a flip. Then the character will be elongated. So it doesn't mean it's impossible to solve this. There are some ways to bypass this behavior, but it would require to make the system a little bit more complex, and it all means extra work. And if you go to the smart layer, I can safely rotate these rotator objects to any custom paths, and after I run the script, everything should be fine. Okay, so here we have a bare character. It doesn't flip when it goes over 90 degrees. Here the character is shortened a little bit, but again you can play with the settings. You can create maybe a custom locator as a center object to get a better result. So for example, here I created a locator. I can group it, constrain the group to the main control, and move the locator in the desired spot. Maybe for example here. Then I can specify this locator as a center object of the transformation, and I can try to run the script again. So here the result might be a little bit better, because again we built the spline through this point, so we don't deform the character that much. So with the spline you can even do the walking and achieve kind of interesting results. And if you have any issues with the legs overextension, we can run the pelvis correction. It shouldn't be a problem. And because neither the NURBS curve or motion paths are created in the scene, we can change these settings dynamically to play with the adjustment. And because all calculation happens in code, the script uses the Bezier curve algorithms, like exactly these formulas to calculate the spline. We can apply a lot of different settings without having bake everything to some NURBS curve each time. Basically it works like this. So you have to imagine that original path of a character is some sort of Bezier curve with some handles. And when we move or rotate the character, this Bezier curve is kind of changed, like it happens in Photoshop or any other program which uses the Bezier curves. And going back to this super complex example, so like I said, the originally smart layer wasn't designed to perform such complex adjustments. The core philosophy of the script is to do simple adjustments. However, if you want to make the character walk over some super complex path, over some terrain, I would say, we can still do this. So the first option which can help us will be obviously helper rig. So the helper rig is some sort of compromise between a simple layered approach and the traditional approach when you create some sort of extra rig in the scene and the curve using the motion path. What we need to know about the helper rig, it works quite well when the number of segments is low, like 1 segment, or maybe 3 segments, or maybe 5. But if we create, I don't know, 50 segments, or maybe 100 of segments, because it all works through script jobs, it might be a little bit slow. Let me show what I mean. Let's select required controls for this rig and add them to layer, set a key in the beginning of the time range. So I will select the main control and create the helper rig. Here we have a super long animation with 1500 frames, and maybe let's create a helper rig with 30 segments. So we will be pushing the possibilities of the script to its limits. I don't think in regular adjustments we need to create 30 segments or more. So let's create the help rig. It will take a little bit of time. Okay, the help rig is created with a super large number of segments. And basically, we can draw a curve manually on the surface. To make this work, we need to make it like a live object. And then we will be able to draw any curve on the surface, kind of like this. So I'm drawing some paths on the surface. And when the path is done, we need to rebuild it to have weight from 0 to 1 and desired number of spans. So here I already created a few curves in my scene. So I have this super long curve going over this terrain with a lot of turns. So what we can do is to select this super complex curve on this terrain, then select the help rig main control. We can find it here in the outliner as well. And we need to press match from curve button. And I will show you the script editor to see that the help rig is updated through script jobs, and it took some time, several seconds, to do this update. So again, when you have super long animations with a large number of segments, it might be a little bit slow. So this option, match from curve, it kind of snapped the help rig to our specific curve, which we created before. And the help rig, it updated all keys of our objects in layer. So right now I have a layer and it has all those keys, and the character is sort of walking on this curve. So right now the adjustment is not done yet. Again, we only positioned the help rig along this curve, and we need also to run the script in the transformation by spline. Again, select algorithm transform by spline. Maybe specify the pivot point for the transformation as usual. Maybe enable vertical rotation if you want. I don't think we need leans. Maybe enable flexible pivot at some degree. And then just run the script as usual. Okay, the adjustment is done. And our character is walking over this complex and long spline on this inclined surface of this terrain. And everything kind of works well. Well, here in these areas, what we need to know is that the script, when it is doing the match from curve option, it is trying to orient these locators to match the vertical direction of a scene. In this case, let's say we would need to manually adjust them to the surface. Again, because there is no any object which would control the twist rotation. So here it works kind of okay. The character is walking on the surface, and then it goes up, then it turns. To avoid issues when the character is going through geometry like this, we have to carefully review our animation before applying the script. Okay, character here is going through geometry, so maybe I will select my relocator set, maybe make it larger to be easier to manipulate, and I can simply select the main control. So using the hotkeys in Maya, I can jump between keyframes and manually check if the position of my character is okay. So for example here, I can find, okay, the helper rig from curve located this locator in order to stay vertical, and maybe I would prefer to rotate it along the actual surface. I can jump between keyframes and find these problem areas and adjust them manually if I want. And important note here, to be able to make such walk on the inclined surfaces using the match from curve option, you have to download the latest version of the script, because in the original 0.9 version, the algorithm was a little bit simpler. It was for only flat surfaces. And right now, like I mentioned, the script is smart enough to understand the vertical rotation and rotate your character, like in this direction, to match the actual incline of the spline. Okay, I spent a little bit of time and quickly adjusted the helper rig in order to fix the character twist. Again, because by default the script is trying to keep the vertical direction of a scene, we might have uncertainty about the twist. So right now, if I run the script, As a result, I got my character walking over this complex terrain, and there is no feed slicing. Everything works kind of good. Character walks over some inclined surface with some twist rotation, and the script kind of handled it pretty well, I would say. Maybe it can be a little bit inconvenient to iterate such a large animation, because again, if you would like to use a different option of vertical rotation or flexibility or other stuff, you would have to bake it again, and the bake kind of takes a lot of time. So like I said, originally the smart layer was designed to optimize simple routine tasks, and adjusting such a long complex shot is kind of very far from a typical routine task, I would say. But we can still do this if we have such request. Okay, this might be it. I apologize for the tutorial being so long, but there are a lot of things which I wanted to show you, and there are still more things which I'd like to show. For example, the root motion extractor, or space switching, or curve filters, and we also should discuss how to create strafe animations, or deal with a human IK rig, and maybe other complex situations. So these all are topics of the next tutorials, and thank you very much for watching, and hope to see you next time.